Morning.
Good morning.
I'm
You
so
got the
tired.
shades on. You've had a rough time in Vegas.
A really good one, though.
Oh, good. Excellent. We missed you yesterday. We were talking about you.
I know. I was still sleeping, then I woke up like around noon, and I was like, "Oh no!" But
All right. Well, good. And you're safely driving home, and you're not driving. You are a passenger,
no,
correct?
I'm the
Okay.
passenger. Yeah.
Yeah.
And then I'm like kind of
She's
like in
back.
the middle of nowhere, so the internet service might kick me off. I'm not sure.
Okay.
All right. Yeah, I'm
All
back. Woo!
Welcome back, Daddy.
Thank you. I didn't lose any money, but I'm like so dead tired.
I bet. Well, at least you're having some fun.
I think
Yeah,
I only
more
got 2
than
hours
the
of sleep.
rest of us, right?
Yeah. It was fun. 2 days is enough.
Oh, thank you. I would assume so. You know what's funny? I haven't been. The only time I went to Vegas was when I was 18. It wasn't even legal to do anything, but my family took me.
Really? You should go. You should go. It's fun.
But if I'm gonna vacation, I want to be not around a ton of people.
You know what? Surprisingly, there wasn't. There was people, but there wasn't a lot of people like there usually is. It was kind of crazy. It was like a ghost town certain hours.
Well, I'm glad you had fun.
Yeah, it was fun.
Good morning. It is We Share Wednesday, so feel free to share. Maddie just shared that she had a great time, but she's exhausted. So, anyone else want to share anything? Nothing. It's so quiet now.
I have something that's kind of cute and sweet. So, I don't know if a lot of you guys know this, but there's a lot of breed restrictions when you're moving places. So we have a dog that is part pit. He's also part lab. He's the sweetest dog ever, but it was challenging finding a place because he was registered under a Stafford Terrier, whatever, and that's the technical name for pit bull. So it was cool because he's a mix, we got the vet to actually, Brian's parents helped us out while I've been in school and doing a lot of stuff. He's working 2 jobs. So I feel like we've been surrounded by really helpful people. So I'm so grateful for that. And then also he's now a lab mix, classified as a lab mix. So it's not going to be an issue if, we need to move in a year from now or anything like that. So I'm really excited because it really sucks to feel okay, I don't want to feel limited, and my dog's not a bad dog. He's a sweetie pie, but it's just cool that he's able to go anywhere now.
Nice. I didn't even know that was a thing. I guess I can never move.
Don't move. You already have a home though, so you're good to go.
Yes, that's true. I'm not moving anytime. I hate moving.
Me too, girl. Me too.
Yeah, I moved. Well, it's much harder after you've been in your house for 15 years, So that move was the worst. Morning, Andrew.
Hey, Andrew.
We were just sharing today since it's We Share Wednesday. So anyone else who wants to share, please feel free. Share away. Oh, by the way, it's food distribution day too. Remember that one we did before that I showed you several weeks ago, We Care Wednesdays? Remember that one? So you can do the drive up food pickup if you're in need of that. Just check out, remember that MCC website where you can find it? So that was just a reminder. Oh, and register for classes. Did anybody register yet? Put your hand up if you did. I didn't. I'm teaching my classes. So I know what I'm taking. Bobby, did you register? Are you done? What's happening? Is it student teaching semester?
I am registering for my student teaching semester, and they just sent the registration code yesterday. So I haven't officially registered for it, but it's not like I'm going to be competing for a spot. They know exactly how many of us are going to be signing up for that course.
Oh,
that's so exciting.
Yeah,
and then you're done.
and then I'm done. I get my own classroom as a legit professional teacher.
Well,
the-
first you have to get
awesome.
hired. First you have to
Yeah.
get hired, Bobby.
Yeah.
Just FYI. There is
Well,
a
I've been
little-
working on my resume. I've been working on my, cover letter, all of that professional development stuff. So it's pretty good. And then the one thing that I'm still waiting for is my like official student teaching letter that places me at the particular
Right.
school and classroom. But that should come soon.
I'm so excited for you. That's gonna, except for the saddest thing about that is I won't be seeing you. You will not be my embedded tutor because you will be at school all day long. That just hit me right now.
Yeah,
That's the worst week or Wednesday ever for me.
I've been sad about it, actually. It's definitely been something I've thought about. So
Oh, Bobby, I need you to train someone.
I am working on it. I'm working with the other embedded tutors. So hopefully, we'll leave you with a good embedded tutor as well.
Okay, yeah, I'm traumatized. But it's okay. I'm so excited for you, Bobby. And yes, you will get a job. I guarantee you. I have no worries about that. It's just it's kind of a annoying part because you're in the midst of student teaching and you'll be interviewing.
Yeah.
So it's kind of a hard, time. You're busy.
Yeah.
So, but
What
you're
age
used
group?
to that.
What age group are you
Junior
looking at?
high and math. So 7th or 8th math, ideally. So
You're gonna have
Yeah.
so much fun and also have your hands full, Bobby. But
Mhm.
you'll do
It'll be
great.
awesome.
I'm excited.
Thank you.
Can you imagine Bobby being your 7th grade math teacher? How fun would that be?
I don't think I would wish that upon him in a million years. 7th grade me was crazy.
Oh, I loved middle school. Bobby, what district are you looking at applying to? Do you know?
I know more principals and like professionals in the Mesa district, but I don't think that'll stop me from applying at maybe Phoenix or Tempe as well.
Nice. That's awesome. I would definitely apply in Tempe.
Yeah, Tempe is your recommendation?
Yeah. I love
Cool.
Tempe. And Phoenix is fine too. You just got to be careful. I mean, not that the districts are bad. It's just a different environment when you look at Chandler, or Gilbert, those types of things. You just have to, kind of make sure it's where you want to be. So.
Junior
Yeah,
high,
I like Tempe. I live in Tempe and I really like it as a city.
Nice.
junior high, I feel like it is a really fun age, but like they are super, super, super rowdy. Because I was
They're
a youth
wild.
leader, for 7 to 9 years. So that's why I was like, you got your hands full, Bob.
Yeah, it'll be good
Yeah.
though.
It'll be so fun. So
My
fun.
student teaching will hopefully be at a junior high, so it won't be like
It'll be perfect.
brand new.
Yes.
Watch
No,
out,
I
watch
taught
out for the
8th
6th
grade.
graders.
Yeah, don't teach 6th grade. Don't teach 6th grade. Only
They're like
7th
the
or
worst.
8th.
Yeah, I
8th grade
agree.
was my favorite. 8th grade was my favorite. That was the best. So, yeah, because they get your sarcasm, but
Mhm.
I was taller than some of them, at least at the beginning of the year, so that was exciting. So it didn't happen for long. Okay, anyone else? We share Wednesday. I was talking about registration. Did anybody register? Only Bobby and I are ready for next semester. Everybody else is not ready. I'm worried now.
I'm working on it, but I have like
Okay, good.
like an admission issue with some of the other colleges. So.
Oh,
Yeah.
annoying.
I'm also working on it.
Okay,
So,
good.
yeah.
I just want to make sure you get it out there as quick as possible so then you can, see an advisor or anything you need to get all that handled. Good. Excellent. Okay, so I have been reflecting on how poorly I explained that game yesterday since we left, but it's okay. I'm almost over it. My 11 o'clock class, I gave clear directions, and lo and behold, they understood how to play the game. So it's amazing how that happens. Once you know the rules to the game, you know how to play the game. That being said, it's okay. I do want to debrief some things about the activity because we went through it and it was unclear and some people weren't here yesterday. So I am going to hopefully share my screen and we're going to talk about that theoretical probability that we started talking about yesterday. So first of all, let's look at this document again. So when we looked at this document, we filled in all of the parts up at the top. Do you remember, like we said, the sum of the two dice, and we could say, oh, 1 plus 1 is 2, 1 plus 2 is 3, and so on. So now what I want you to do, I don't know where it went now. Let me look. Might be here. Hopefully it's this one. Nope, it's not. Maybe it is. Okay, let me see. Anyway, we'll go back to that in just a second. Let me look. Let me find this document. This is the document I want to show you. Okay, so this is what we did. So 1 plus 1 is 2. This is theoretical probability, not our experiment. But a lot of you noticed some things yesterday when you were doing your game that, oh, 6s, 7s, 8s came up a bunch, right? And some of us 11s came up a bunch yesterday, if I remember. But what I want you to do right now is I want you to calculate the percentage of each of these. And I think we talked about it yesterday. We just did one of them. Do you remember that? Okay, so I want you to calculate the percentages. So if we go back to this doc, right here, and we can fill in, for some reason, oh, there we go. I can write on this, maybe not. No, can't. Down here, why can't I write on this? That's very annoying. Okay, but what I want you to do is figure out these percentages. So if we have these percentages, I guess I can maybe type on here. Maybe it will let me type on here. So possibilities, there was no way to make a 1. There was, how many ways could we make a 2? Do you remember? Seven was the most, right? 6, 5, 4, and then this went back down the other way. All right. So, and then out of this, this was, Mackenzie told us yesterday, I'm pretty sure that this was a 6 by 6 grid. So these were all 36s, right? There's 36 possible outcomes. So if we're finding probability, you could take the number possible over the possible outcomes. So you could say 0 over 36, so there's no chance of getting a 1. There's 1 chance of getting a 2, or 1 out of 36 chance, sorry. And, and so on. So if we calculate this percentage for each one of these, this would be 0%. We know that one. If you could round these to the nearest 10th, that would be great. So if I do 1 divided by 36, I get 0.027. If I multiply that by 100 to get my percentage, I'm going to get 2.8%. Okay, so can you figure out the rest of those percentages right there? And then we'll talk about them. Okay, I hope you're almost done. We'll go over them in just a minute. Malik, who was your partner yesterday?
Um,
I can't remember. Was it Annie? Annie,
yeah,
were you Malik?
it was Anorak, yeah.
Okay, perfect. Just making sure. Clementine, who were you partners with yesterday? Nulissa. Okay, thank you. All right. So let's look and see how you did on those, because now I want us to compare with our experimental data. So you should have gotten these percentages. Why won't this move over? Huh. Weird. Okay, so you see that you have, did you get 2.8%, 5.6%, 8.3%, 11.1%? This is good rounding practice for us again. 13.9%, 16.7, 13.9, and then it goes back down. See if I can drag this over here. There we go, that's a little bit better. Okay, so this is our experimental results. So remember that spreadsheet we did? Okay, so the top is theoretical probability. That's what should happen. Those are the possible outcomes divided by the total outcomes. Now, our experimental data is what actually happened. So between all our classes, there were 3,850 rolls of the number, okay, of each, total rolls, I should say, okay? So if that's the total rows, then I totaled in that spreadsheet all those columns. So there were no ones rolled, right? Because that's impossible. So our percent right here would be 0%. Oh, apparently I'm not allowed to write on this document. So that's a 0%. To figure out the experimental probability for 2, you would take 144 and divide it by 3,850. When I did that, I got a decimal, I multiplied by 100. Our probability of 2s for our experimental data was a little bit higher. It was actually 3.7%. So for ours, it was 3.7%. Calculate all the experimental probabilities, and then we're going to compare these two, okay? And I can put this doc in the chat, and you guys can make a copy of it if you choose. So let me do that real quick too. So find all of those percentages. So if you've already finished, I want you to compare your experimental to your theoretical. And I didn't make these numbers up. These are from the spreadsheet. Okay, so did you guys all finish? What did you notice? Are they close? Are they not close? Because one was experimental and one was theoretical.
They're close.
Okay, Kate, what makes you say they're close?
It's only, for majority of them, it's only 0.2% off from the theoretical probability.
Okay, so in our experiment, which one had the highest probability and what was it in our experiment? And it's not for Kate, this is for everyone. So Kate can answer, but anybody else can answer as well.
Say that question
7.
again.
So which one in our experiment had the highest probability and what was the percent? And Andrew said it was 7. So what was the percent in our experiment? Victoria, what'd you get? When you calculated the percent for 7.
I didn't even finish it. That's how.
So you didn't get to 7? What'd you get for 2 then?
For 2, I got 62.3, but I could be wrong.
So did you divide 144 by 3,850? Does that seem a little high?
And then,
try it again, Victoria.
Yeah. Okay.
So 62%, that would mean. So just divide 144 by 3,850. And then when you get that answer, multiply it by 100. What'd you get now?
I got 0.4254.
When you did 144 divided by 3,850?
Yeah. Unless
No
I'm
way.
doing it
You better
wrong.
get your calculator checked. Okay. Jonathan, what'd you get for 2?
Sorry, 3.7%?
Yeah, 3.7%. Excellent. When you do 144 divided by 3,850, you got 3.7%. And Maddie said she got 3.74. Remember, just round to the nearest tenth.
Okay.
So, did you figure it out, Victoria?
I got it. I
Okay,
was off
good.
by a number.
Okay, good. Clementine, what did you get for 3? What was the probability of 3?
I got 6.2%.
Very nice, 6.2%. Malik, what'd you get for 4?
I need to like see the questions because mine are kind of switch devices, so I can't have mine up right now. Did you put it in the chat?
No, I just showed it on the screen and I gave you like
Yeah.
5 minutes to figure it out. Ben, what'd you get for 4?
Give me a second. It's lost in the calculator. 8.5.
Yeah, how many of you got 8.5% on that one? So that doc is in the chat. Excellent. So, and then for 5, Leslie, what'd you get for 5? What was the probability or the percent?
11.4%.
11.4%. Excellent. Caitlin, what did you get for 6?
13.8%.
Very nice. And then for 7, what'd you get, Annie?
Wait. I got 16.4%.
Excellent. Perfect. And then for 8, Zevi, what'd you get?
I got 12.6%.
Excellent. And then for 9, Bree, what'd you get?
I got 11.3%.
I think I got 11.4%.
Oh yeah, sorry. I just saw the 5. I didn't
Perfect.
round.
Just making sure. We just want to practice rounding too. Excellent. And then for 10, AJ, what'd you get for 10?
Remind me, what was 10?
10 was 316 out of 3,850.
350. 8%.
8.2%, right?
Yeah.
Make sure you round correctly. All right, and 11. Who haven't I asked? Sine.
I got 5.5%.
5.5, excellent. And then 12, Maddie, what'd you get?
It looks like her. Oh no.
I was going to say, we may have lost her. So, all right, for 12, I got 3.1%. So now I'm going to share my screen with you so you guys can see them next to each other. The reason I wanted to do that is because that's a really important thing. So do you see up here is the theoretical probabilities, and down here is the experimental probabilities. Theoretical probability is found just by counting how many successful outcomes out of total outcomes, not doing an experiment. That's from that chart where we notice that we can't make any, there's no way to make a 1, there's one way to make a 2, and so on. And so here's our theoretical probabilities in percentages. I could have written them as fractions, but then my experimental probability is down here. And if you compare, so our 2s are a little high, right? 3.7. Our 3s are a little bit high, 6.2 compared to 5.6. But our 4s are really close. Our 5s are fairly close. Our 6s are pretty close. Our 7s. Our 8s are a little low, which surprised me. It must have just been our class where they were high. And then our 9s and our 10s and our 11s and our 12s are all pretty close. So what's fascinating about this to me as a statistician is if you would have just taken your own group's results, like any pair of you, you might not have been real close to the theoretical probability. But the more times I repeat an experiment, the closer and closer and closer I get to this theoretical probability. So we did 3,850 rolls. If we would have done 10,000 rolls, we would have seen it would get even closer to it. So this is not made up data. This is data that we found when we did our rolling experiment yesterday. This data is data we just calculated, not from an experiment. So do you see the difference between theoretical probability and experimental probability? And what's nice about this is, did you notice that it still did go up? 7 was still the highest, and then it tapered off on the end. Any questions on this data? All right. So now I'm going to show you one other thing. This right here, here's all our options. This is theoretical probability right here. Do you notice what shape it approximates? Do you see how it's that bell curve like we talked about before? Yeah, so it's a symmetric distribution and 7 is right in the middle. So this is a nice way. And remember that 7 is right over here. You can see 7 is the most popular result because there's 1, 2, 3, 4, 5, 6 ways to make a 7. So the probability as a fraction is 1 out of 6 because that's the simplified fraction of 6 over 36. And then notice over here, here's your percent, right? Or your probability. We said it was like 16.7%. So do you see how this picture is showing you the same thing that we just saw on our chart? Excellent. So this is how statistics developed, is we ran a bunch of experiments and we figured out, oh, this always happens. So we must be able to apply some mathematics to this and develop the whole world of statistics, which is related to probability. All right. So you had an exit ticket yesterday. And the exit ticket yesterday, I can't remember what number. Did it say what's the probability you roll a 4? Is that what it was? I think it was. So
Well, we're asked if they had run a red light in the last year.
What? Someone saying something to me? No. Okay, just checking. Okay, so last night your exit ticket was the probability of rolling, I think it was a 4. And some of you got it right and some of you didn't. So let's just talk about what that would mean before we do these other examples. So if we're just rolling one normal 6-sided dice, how many 4s are on there? Yep, Maddie, there's only one, thanks. There's only 1 4 out of a total of how many numbers are on the dice? There's 6, right? So it's going to be 1 out of 6. That's the probability. It's that simple. Like, don't overthink it, right? So it's successes over total. So now, if you were going to do this one, find the probability of rolling a number bigger than 2. So it can't be 2. It has to be bigger than 2. And again, we're just doing one dice. So I want you to think about it for about 30 seconds and then get your answer ready in the chat. You guys are awfully quiet, yes, in today. So I want to make sure we're all on the same page. Yay, good, Victoria. I'm glad the mini lesson helps. Okay. So you're finding the probability of rolling a number bigger than 2. And get it ready in the chat. Just write the fraction. Just write the fraction. It'll be way easier. I think I computed all of them, but just do the fraction. All right, in 3, 2, 1, go. Nice. So it looks like I'm still getting some answers. That's awesome. So some of you wrote 4, 6, and then you simplified to 2/3. That's totally fine. The 4/6 actually helps us understand the problem, right? And then we just know how to simplify fractions. So the 4/6, you would get that because a number bigger than 2 is a 2, is not a 2, is a 3, 4, 5, or 6. So there's 4 numbers out of a total of 6 numbers. And then you can simplify that fraction. Excellent. How about the probability of getting a 7 on a 6-sided die? Think about that for only about maybe 15 seconds. What's the probability of getting a 7? You're still throwing 1 dice, okay? All right, and 3, 2, 1, go. I have 17. Is that everyone? I don't think so. Make sure everybody's answering. Okay, so 0, there's no chance, right? It's an impossible event. Excellent. So it's 0 out of 6, which is simplifies to 0. Very nice. Those are nice questions for the test because sometimes you guys have a panic attack and you're like, wait a minute, what's happening? There's no way to get a 7 if I roll a 1 6-sided die. So there's our answer. Okay, and we could write it as a fraction, we could write it as a decimal, or we could write it as a percent. And if we ask you for the decimal or the percent, we're going to be specific on where we want you to round to. If we're just asking you for the fraction, we just want a simplified fraction. Any questions on that? Okay, let's do another one. Suppose you write each letter of the alphabet on a different slip of paper and put the slips into a hatch. So you write A on one slip, B on the next slip, and so on, all the way to Z. It says, what's the probability of drawing one slip of paper from the hatch and getting a vowel or a consonant? First of all, do you know what a vowel is in the alphabet? We're only going to go with A, E, I, O, U. Those are our vowels. Okay, everything else is a consonant. So go ahead and calculate that and let's see how you do. All right. Did you get them both? Let's just do the vowels first. Let's do a 3, 2, 1 chat. How many letters are in the alphabet? Anybody? 26. There's 26 letters in the alphabet. Okay, so you might need to revise your answer. Are you ready? In the chat, 3, 2, 1, go. Very nice. 5 out of 26. And someone gave me the percent. Excellent. Because we can give probability in fractions, decimals, or percent. All right, now how about a consonant? What
I don't know that one.
Okay, so the consonant is going to be everything that's not a vowel. Okay, everything that's not a vowel would be considered a consonant. So if there's 5 vowels, how many consonants are there? Very nice, Maddie. 21 out of 26. There you go. Good job. Excellent. I'm just going to flip it to the next page so you can see it. I have a little explanation here for you. There's 5 letters for the vowels, and there's 26 total letters in the alphabet, so that's 5 over 26. All the other letters in the alphabet are considered consonants, so that's 21 out of 26. Now, the letters in the alphabet, we're either going to classify them as vowels or consonants. So together, they must total 1 or 100%. So if you took 5 over 26 plus 21 over 26, you would get a total of 26 over 26, which is the same as 1 or 100%, because that's all the possibilities. Any questions on that? All right. So I'm going to have you guys work in groups on partner practice. Let me get this doc for you and put it in the chat just so you can have it once you get to your room of these problems. Where did I put them? Hold on one sec. Okay, so this should be the doc, and it shouldn't take you too long. I just want you to do number 1 first, and then if you finish, go ahead and do number 2. Okay, but number 2 is about a deck of cards, and some of you may or may not know a deck of cards. So I did provide a deck of cards to you, okay, in the handout. So if you take a look at that, and you can just view it if you want and write it down on paper, or you can make a copy of it. So I'm going to put you guys in your breakout rooms. These are the same rooms you were in yesterday. Carmen and Maddie, neither of you were here, so you two are in a room by yourselves, okay? Well, not by yourselves, but together. How's that? And then Bobby or I will come in and make sure if you need help. Okay, so try at least problem 1 in your room. So make a copy of that doc if you need it. Sine, AJ, Malik, are you all in a breakout room?
No, I didn't get the notification.
Okay, Malik, you should be in Annie's. Let me
You
find
with
Annie.
Victoria and like all that.
Annie, number 5. So there you go. All right, so Bobby, hold on one sec. Let me stop sharing
Yeah,
my
no
screen.
problem.
Let me. Welcome back. Bree, were you all done?
Yes, I was.
Excellent, good. Zevi, good job. Thank you for being patient. AJ, how'd you do? Did you finish them? Yay. Uh-oh, Maddie, what happened? That's perfect. Go to Flagstaff. Spend the day there. You're good. Enjoy the cool weather. It is not cool here. It's just a nice scenic detour. It's all right. Okay.
I'm supposed to be like the co-pilot over here telling them where to go, and I'm like, dude.
Nope, no co-piloting when it's math class, right? Tell them sorry.
No.
It's okay. It'll be a nice detour.
Yeah.
Hello.
All right. Welcome back. So I don't know how far you got. I only got to visit a room or so. So I know Bobby might have been jumping around, unsure. Let's have you check your answers, okay, to make sure you're on the right track. And then I want to talk to you about decks of cards, okay? Because not everybody is a card player. Is there anyone in here who likes cards or has grown up playing cards? Okay, so Ben, anyone else? Bobby, Kate, AJ, excellent. Anyone else?
Kind of.
Okay, is there
Andrew and
anyone
Mackenzie.
who, oh good, Andrew and Mackenzie. Is there anyone who does not know decks of cards? Like, it's really hard for them. Is there anyone in the class that's like that? Like, who's never really played with a regular deck of cards? Okay, a couple of you. So this part of the probability is going to be hard for you. And it's really hard because you don't know the cards. And we'll talk about that in a minute. So when you did that first question, the probability a red ball is drawn, did you get these three answers? And please tell me you read the directions on the worksheet and you saw that you were supposed to give all three answers: a fraction, a decimal to 4 decimal places, and a percent. Yes? And then this question wasn't numbered on your paper, which was a little weird. I don't know why I did that, but it said compute the probability of rolling a 12-sided die. So now it's got the numbers 1 through 12 on it, and you get a number other than 8. So did you get that one where there's 11 numbers that aren't 8? And so you would get 11 out of 12 or 0.9167, or there's a 91.7% chance you're going to not get an 8. Any questions on those three?
No, but I think you like being tricky, Roxanne. I didn't notice. No, in a good way though. Like I didn't notice that it was. So when I was reading the problem and it said 8, I initially did 1/12, and then I like reread it, and I was like, okay. I did the 11/13, and then initially I put in like percentages and a decimal place, but then you had the decimal place 4 ones out, and then the percentage I think you did 3 ones out. So I was like, oh, you really got to read the instructions.
And Mackenzie, I'm so happy you noticed all of that. It is really, you have to pay attention in assignments, right? And make sure you're reading the whole thing. And also, here's an interesting thing is, Mackenzie, if you found your 1/12, did you have to go back and redo all the math, or could you have done something different to get your answer of 11/12? Just curious.
Well, I mean, I just deducted the 1 from 12, so you just did 11/12. So
nice. And you could even have done it with your decimals as well, right? You
but
could
yeah,
have
I
done
had a good teammate though, because Sine was like rereading the stuff too, so I can't take credit for everything. So we did it.
That's
tag teamed it.
Terrific. Okay. Oops, I didn't mean to write all over my screen. So now any questions on any of those? Mackenzie said she had to be careful, right? And Sine was a helper. That's why it's nice to be in a team of 2 instead of just all alone, right?
I was just lost the whole time. Lost.
So make sure you're reading directions carefully, right? That's a key. Anyone else? Need clarification?
I think for me, I just think of math, and I think that every problem's going to be hard. So when Kerman's like, it's just 1, and I'm like, oh yeah, you're right. I'm trying to find like everything hard about it when it's not always the case.
Yeah, I don't think that's the biggest thing about probability and statistics is the mathematics isn't that hard. It's the thinking part that's hard. It's making sense of the problem and understanding. That's the hard part. So some of you are like, oh, I'd rather just have the math, right? But that's why statistics is a different type of math. Okay, so let's talk about a deck of cards. So I have a picture for you, and if there's anyone who does not know a deck of cards, I did put it on the handout for you. And when you take your test, there will be a picture like this of the deck of cards. So if you're struggling, you know that the deck of cards are here. So just so you know, let's go over some brief things. There are 52 cards in a standard deck. That does not count jokers, okay? It's just these 52 cards that you see right here. Notice that they're in lines of, right here, you have 4 different lines right here, and they have a different shape on each one of them. So those are called suits. So this is spades, this is hearts, this is diamonds, and this is clubs. And if you're trying to keep track of those words, spades, you could write on your handout so you know these are spades. That's supposed to look like the end of a shovel, okay? A spade is also known as a shovel, so that's what that shape is. So if you remind yourself, oh, it's a spade because it looks like a shovel. And then hearts and diamonds, I think you're fine. And then these are clubs, and the clubs kind of look like a clover. So some people who are not familiar with cards might not know that there's 4 suits, and the suits are spades, hearts, diamonds, and clubs. Now notice that the clubs and the spades are black, and the hearts and the diamonds are red. So half of the cards are black, half of the cards are red, okay? In each suit, you have ace through king. And ace, depending on what game you're playing, could be a high card or a low card, but it is definitely not a face card, okay? Because there's no face on the card. The face cards are these over here. The face cards are the ones with faces on them. So jacks, queens, and kings all have faces on the cards. So those are called face cards. Make sense? Okay, so there's 13 cards in each suit, ace through king. So you see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 cards in each suit. So there's 26 red cards and there's 26 black cards in the deck for a total of 52 cards in the deck. Any questions about what a deck of cards means or is before you start doing the problem? Yeah, so when you do your probability homework, there's lots of questions about cards in them. So that's why you'll want to have this resource available to you. Okay. Okay. Did it again. Okay. So now these are the next questions on your worksheet. Let's do one of them together, and then I'll put you back in your breakout rooms to finish the other 2. Is there any group that was already done with all of the card questions too?
Me and AJ are finished with our card problems.
Well, good. I have more problems for you.
Okay.
So I'll send you another sheet. You'll never run out of activities to do. So if we look at this, so good. Bree, can you tell us what the answer is to the first one where it says, what's the probability you get a king?
So I got 4 out of 52 and I simplified it to 1/3, which would give you a decimal of 0.77.
Hold on a second. 4 out of 52 simplifies to what?
Let me double check now that you say it. 4, 52. 113. I'm sorry, I just typed it wrong.
There you go. I figured you did. So 1 out of 13. Now, can you tell us where you got the 4 and where you got the 52? It sounds obvious to you, but maybe not to everyone.
So there's 52 cards in a deck. So I use that as my, what is that, the bottom number? And then I looked, because I'm not great with cards, but I still really like to see them. So I went up to the picture and I counted all of my kings up. And I put that over 52 to get 1/13.
Very nice. If you look, there's a king in every suit, right? So there's a king of hearts, a king of diamonds, a king of clubs, and a king of spades. So there's 4 out of a total of 52. And then you simplified that to 1/13. Then as a decimal, you got 0.0, oops, I'm not writing, 0.0769, and then as a percent, you would get 7.7%. So your guys are going to do the same thing in your rooms. I just put a comment in the chat with more problems on it, okay? So did you see that new doc in the chat? That new doc has more problems on it. So those of you groups that are done, start working on that. Oh my gosh, it's 10:10. Where did the time go? That's crazy. I'm not even going to put you in groups. I know some of you are like, I was looking at the clock the whole time. Time does not fly. I watched every second go by. So it's okay. Okay, I'm going to be quiet for just 1 minute or 2 minutes for you to finish these 2. And then I'll put up our exits again. We'll talk about tomorrow.
Okay, I gotta go fish. I'm gonna go to the bathroom and then I need to get going. Okay.
Roxanne, would you mind resending it through the chat? It booted me off. I'm working with my Wi-Fi. It's kind of giving me troubles lately, but if you wouldn't mind sending me the link again through the chat, I'd appreciate it.
I think I just pasted it for you.
You're on mute.
Thank you for reminding me. So let's see if you got these answers. I didn't write the decimal and the percent, but you could have and you should. On this one, the decimal will be 0.25, the percent will be 25%. I know that one because it's 1/4, right? So 12 out of 52 for the face cards. Did you guys get that one right? Yes. All right, and there's the decimal and the percent. So we'll continue working on this stuff tomorrow. I know on your exit ticket that I'm going to show you, see, because I have lots of poster problems and practice problems. The practice problems is what I just sent you. You do not have a mini lesson due tonight, but you do have this I'm changing right here. I made that due tomorrow night, so don't worry about that one, but definitely do your PC1 homework, okay, which is your introduction to probability practice. And then I'm going to put your exit ticket in the chat. If you're struggling with this material, you need to make sure, I'll make sure I post the slides in our Canvas course, watch the recordings, and then make a scheduled visit with Bobby in the tutoring center or any other tutor. And you can do that on a regular basis because you don't want to continue down a path of not understanding, because you're going to have another test on this, you know, in a few weeks, and you don't, maybe you need to improve your score or maybe you need to keep your score. Okay. Excellent. So great. Have a great day. Tomorrow is Thunderbird Thursday. Come ready. Make sure you do that exit ticket. And let me know if you have any questions.
I'm out of here, guys. Thank you.
Bye, Andrew.
Bye.
Bye, Maddie. I hope you make it home safely.
Me too. I'm ready to go lay down on my bed and take a nap and then do all this good math stuff.
Yay, good.
So look at the shirt I have on today. I mean, it's not a shared t-shirt, but it says day drinking and naps.
Nice.
And that was
okay.
me.
As long as you're not day drinking and driving, you're fine.
Oh no, I would never.
Good. All right. Anybody have questions? You can
All
stay
right,
on
you
here
guys
if you're still. Bye, Mackenzie.
I'm going.
Bye.
Bye-bye. See you tomorrow.
Bye, AJ. All right.